Hello everyone, I hope you all are doing well. Today in three-dimensional geometry we are going to discuss prism. By definition we know that it is a solid shape consisting of two identical ends and also flat surfaces. First, understand the structure of a prism. If we draw a polygon on the paper, let's say I have drawn a triangle, then imagine extending it up from the paper. By this process, we will find a 3D figure which is called a prism. Because we are extending up the polygon we have drawn, that means we will find the polygon once again, and that will become the another end of the prism. That is why we have two ends or bases of the prism. Here you can see ABC was a triangle which we imagined lifting up on the paper. Then we found one more triangle, that is triangle GHI, and the overall figure we got is called a prism. That means for a prism we get similar two ends. That means triangle ABC and GHI both should have same dimensions. If these ends, or particularly these two triangles, are not same, then this particular shape is not a prism. Now let's recall few terms. Face is the flat side of the 3D object. Edge is intersection of two faces, and vertices are where edges joins. So basically vertices are the points. So we can see from the figure are two bases, 9 edges and 6 corners, or we can say vertices of a prism when the base is triangular. On the basis of the polygon we have used as the base, we name the prism. So this particular prism is a triangular prism because we have chosen triangle as a base. So in total there are 3 vertical faces and 2 bases. So in total there are 5 faces or surfaces of a prism. If we have used the polygon of 3 sides, then double will be the vertices, that is 6. Now let's see what is the cross section of a prism. Know that cross section is the shape which is obtained when a plane cut a 3D object. In this particular case you can see if the plane cut the prism at the points D, E, F, then we get the triangle. Even if we change the height of intersection, then also we get the triangle again and again. And this triangle is exactly similar as the base itself. That means cross-section area of triangular prism is a triangle. But if in case of triangle we take another polygon, let's say square, then we will get the cross-section as square. If it is a hexagon, then the cross-section area would be a hexagon again. So in general we can conclude that the cross-section of the prism is exactly same as the base. One more thing you should notice here, that if we talk about vertical surfaces, so number of vertical surfaces or faces is also same as the number of sides of the polygon. Along the sides CA, AB and BC, there are 3 parallelograms, or specifically we can say rectangles, if the triangle is equilateral triangle. So if in place of triangle we had a square, then we needed 4 vertical surfaces to make a prism. Now for the total surface area, all we need the surface area of the base, or here specifically the triangle. Then we can multiply it by 2 because bases are similar. And then in this we will add the area of these 3 rectangles. That will be the total surface area of the prism. So the general formula for the surface area of any prism is 2 into base area plus perimeter of base into height. Because what we will do in finding the perimeter of the base, AB plus BC plus CA, and then we will multiply with H. So AB into H will be the area of one rectangle, BC into H will be the area of second rectangle, CA into H will be the area of third rectangle. So you can use the formula either ways. All in all, what we are doing, we are simply finding out the area of all the surfaces. That is why in 3D shapes, all we need to understand is the structure of the shape, because ratification of the formulas is not the solution. The prism, what you are seeing right now, is just one type of prism. As the base changes, you will get different type of prism. So along with learning the formulas, you will understand the concept. And for that, I am going to open the net of the prism. We know that what a net is. Net of a 3D shape is a structure that what it's look like if we open that particular 3D shape or object. So you can see I have opened the prism along with one of its base. So what we have discussed so far will be more clear with this net. Because of three-sided polygon, we have three rectangles, or in general we can say parallelogram. On the basis of this structure, we can simply find out the volume also. So for volume, again, all we needed is the area of the base, and we will multiply it with the height of the prism. In this case, because we have taken the example of an equilateral triangle, so all these vertical lines are perpendicular on the base, so we can take any of this vertical line as the height of the prism. So for better understanding of prism, we should have proper understanding of polygons. Because ultimately we need the area of the polygon which we are using as a base to find out the surface area or volume of the prism. Now sometimes we get confused in between the structures of prism and pyramid. So let's clear the confusion on the basis of simple basics. You can see I have made this pyramid on the same base, that is a triangle. In prism we have two bases or two ends which are exactly similar, but in case of pyramid we need an apex. In this example, that apex point is E, and the vertices of the base are being joined to this apex point. That is why we have only one base for a pyramid. For the height of the pyramid, we need to make a perpendicular from the apex point to any side of the base, and then we go on with the formulas. I have already covered all the theory and formulas of pyramids in a separate video, so I am not going to take it further. I just needed to clear the confusion in between prism and pyramid, so I hope it is clear. And on the basis of net also I have shown this. One more prominent difference which you can see in the net of pyramid and prism, and that is the vertical surfaces or faces are always triangle in case of a pyramid. But in case of prism, vertical surfaces or faces are always parallelograms. On the basis of what we have chosen as the base, there are various type of prism, out of which one is regular or irregular prism. If the polygon we have chosen is a regular one, that means all sides are equal, then it is a regular prism, as we have taken in the beginning, which was a equilateral triangle. But now if I take a triangle which is not an equilateral one, then this particular prism will be called as irregular prism. Rest of the properties are same. We have 3 vertical surfaces. Though it is irregular, but both the ends or faces of base are same, exactly same. What can be changed? Maybe just the formula what you are using for the base triangle, because maybe for equilateral triangle you would be choosing to use the formula for the equilateral triangle area, but not for this one. Rest all properties and formula will remain the same. I have mentioned all type of formulas which we use to find out the area of a triangle in different cases, whether it is equilateral or not, if the height is given or not, or maybe all sides are given but not the height. So you can just go through once. These all formulas will be beneficial for you. Now next type you are seeing is an oblique prism. As the name suggests, you can have an idea. If upper base is right above the lower base, that means joining lines are perpendicular to the base, then that is called a right prism, which we have taken in the beginning of the video. It is called right prism because the vertical edges are making right angle with the base sides, and that is why in that case vertical faces are rectangles. But in case of oblique prism, upper surface is definitely parallel to the lower surface but not right above. DB, EC, FA, these vertical edges are not perpendicular on the base, so we cannot consider it as a height of the prism. Also, these vertical surfaces are not rectangles, these are parallelograms, because DB, FA, EC are not perpendicular on the sides of the base triangle. So when we have taken only one case, which is a triangular prism, then only we have got so many types. That is why it is very important to understand the structure and these type of nets of 3D structures, because it is not possible to learn everything. Once you understand the structure, you have no need to learn the formulas. So by net also you can see that these lateral surfaces are parallelograms. But here also triangles are exactly similar, because that is the basic requirement for a prism, whether it is a regular one, right one, oblique one, or irregular one. When we take another polygon in place of triangle, that I'll be covering in another video, but through all the net what we have yet elaborated, one thing we have noticed that in the prism only polygons are being used, not only for the base but also as the lateral surfaces. That means anywhere, either for the bases or for the lateral surfaces, if we are using curves, then that will not fit into the definition of a prism. For example, if you take the example of a cylinder, Because we are using curved surfaces, even though the bases are 2 and parallel to one another, we cannot consider it as a prism because we have not used the polygon but a curve. I hope this video was useful. Thank you so much for watching. Bye bye.